welcome back to the workshop. I thought I'd share this job with you today. It's a chronometer that I'm in the process of carrying out a restoration on, and it's had a lot of damage inflicted to it over the years, partly by a poor restoration attempt that had happened in the past, which had caused a rather damaging run through, which is where the fusee chain had failed and the sudden release of power had destroyed several components, or at least very badly damaged them. One of the components that has received a lot of damage is this wheel here. I don't know if it will come into focus. Yep, maybe. And you may be able to make out there that there are several bent teeth. Now, with this being an original wheel, which is otherwise in very good condition, I feel loath to replace the wheel. I would like to keep it, as if at all possible. But with it being a chronometer, I don't really feel like just cutting in a section and filing the teeth up is appropriate. So what I'm going to try and do is to cut the section out, add a new section in, which will probably be riveted in, hammer hardening the brass as I go. Then I'm going to make up a holder, and after removing the wheel from the arbor, I'm going to mount the wheel onto a holder and actually cut the teeth on the Chronometer 102. Put the other lens on there, so hopefully you might be able to get a slightly better glimpse of the damage. Here we are. You can clearly see that several of the teeth are damaged, and those are the teeth that I'm going to replace. You can see there where the fusee chain actually lashed the tooth. So I'm going to cut that section out, hammer in a piece of brass, then remove the wheel from the arbor, which is a shame, but hopefully I'll be able to get it on and refinish that area and make it look as good. And then I'm going to cut the teeth in the Chronometer 102. So with chronometers, what's often the case is that you end up making tools just to work on the item. In this case, for me to drive the wheel off safely, I can't use a stake because it bottoms out on the top of the pivot. It's actually bottoming out on there, and it's not making it all the way to the bottom where it would be safe to press down. So what would happen is that would either bend or break the pivot. So that's out of the question. So we'll have to make a stake to suit to be able to drive the wheel off the arbor. Okay, let's just face this off. I'm using silver steel here. I'm cutting it with a high-speed steel cutter. Just spotting the centre. and then I'm going to use one of these carbide drills, which I highly recommend from Drill Service Hawley. The silver steel is quite tough, so a carbide drill does help. Okay, so we're back with the tool made, which looks something along those lines, which we can now use to carefully drive the arbor out of the wheel. Like so. And we didn't inflict any damage to the wheel. And likewise we didn't inflict any damage to the pinion. So far so good. Next job is to make up a holder. So we'll just measure the pinion and see what size the centre bore is. So it's approximately 3.46. So we'll start with 3.5, I think, and tweak it to fit. Right, so we'll make a holder for the wheel so that we can machine the teeth. I'm using the Smart & Brown, which is a lovely machine, and I'll be using that to just rough out this holder. I won't be doing the precision machining on it, but it's just a luxury to have a machine like this set up ready to remove bulk metal. What I'm doing now is to drill the holder for the size of a piece of silver steel that I'm going to use. I'm going to use the silver steel as a centering peg. So we'll just fettle that to fit, and then that's going to be a centering peg that can be accurately turned down to centre the wheel onto the holder. Right, so what I've done so far is I've made up the holder with a steel pin, and that is very precisely dimensioned to the centre bore of the original wheel. So you can see that slots on there really nicely. I'll show you closer up in just a moment. And I've also made a piece that sandwiches the wheel in. So this is how we're going to cut it, so that it's fully supported. Next stage will be, we're going to screw, I'll probably use 4 screws, why not? We'll screw the components together. So I need to just mark out the location of some screw holes. There we go, nice and accurately divided there. So I'll drill some holes now and we can fit some screws. So just a little bit closer, you can see the steel centre pin. And if we get the wheel very nicely drops onto there, and then that piece will drop on top, and there will be 4 screws to sandwich the whole thing together so that it's nicely supported for cutting the teeth. Right, so now we've got the holder made. I drilled and tapped the holes off camera. I've got some screws here. So the next stage, well actually the next stage will be to turn down this to the root diameter, or even slightly less, so that I can accurately locate the wheel in orientation to the cutter. But when I've done that, which I'll do off camera, we'll be assembling the stack. So the wheel will go on like that, and then I've got a centre mark, yeah. Then the top piece will go on like this, and it all screws together. I'm going to just turn down the plate here that's going to sandwich the wheel against the rest of the holder, and I want to do that just so that when we present the cutter, when we're mounting this up in the machine shortly, I want to be able to get the cutter into the tooth and align the wheel's orientation with the dividing head, essentially, get it all in sync so that when we come to cut the teeth, we're cutting them in the right place, because that's the object of the whole exercise, is to try and make this an accurate repair. So I'm going to cut it down to the root, just a little bit beyond the root of the tooth, which according to my calculations is approximately 16.2 I think I'll go for. Right, so the next stage is starting to look at what size cutter we're going to use to cut the teeth. So first thing to do was to count the number of teeth on the wheel. You can just make out the black marks. They're Sharpie marks where I've been counting the teeth, and we've come up with a figure of 64 teeth. Sorry, 64 teeth. That's the number of teeth that are already on the wheel, so obviously that has to be the same. I measured the OD as accurately as possible and came out with 18.45. So we can then use the standard equation here that's used in wheel and pinion theory, which is OD over the number of teeth plus 2.76 for a wheel. That's different for a pinion and is also different for different pinion counts, but for a wheel it's 2.76, that factor. So that comes out with these figures here. 18.45 is the OD, 64 is the number of teeth, and plus 2.76. That comes out theoretically at 0.28 is the 0.28 is the theoretical module size. The cutters come in 0.05 increments, so the nearest cutter to that is 0.3. I've got 0.25 as well, but I've had a look, and the 0.3 cutter does fit very, very well. So even though this wheel originally wouldn't have been cut using commercial cutters like this, this commercial cutter does fit this wheel very, very well. So the wheel is conforming to the theoretical sizes. So that's the cutter that we're going to use, 0.3. I'll bring you in a little bit closer and see if I can just show the two cutters, 0.25 and 0.3, in the teeth, so you can see the difference. Right, so here's the wheel, and you can see the black marks that are me marking every 10th tooth while I've been counting. This is a 0.25 Thornton's cutter, and you can see the tooth profile. If we present this cutter to this wheel, you can see there it's quite sloppy. I'll try and get a better shot than this. Okay, so I've got in a little bit closer. See here the cutter, and if we present it to the tooth, you can see it's actually quite sloppy in there, and also something that doesn't quite come across on camera, but you can see it's quite sloppy, but it doesn't actually make it all the way to the root of the tooth. You can see there's a gap. However, with the 0.3, we come in with that. You can see here, fills that gap really nicely. It's hardly any slop, but it's just nicely free, and it goes right out to the bottom of the tooth, filling that space very nicely. So that's the cutter that we're going to go with.